If I quickly explain you the motor working principle, this can be well elaborated in 1 week program where you get to brush up your electrical knowledge as well. So what happens inside a brush type DC motor, you have a brush arrangement over here, and whenever the current flows through this wires, this particular rotor is going to rotate, and this commutator is going to transfer the current from one coil to another coil. And here is what happens when you consider a single loop, very simple DC motor. So this is one wire. This ABCD is a loop of a wire supplied by a terminal voltage VT. So what happens due to induced EMF inside this coil, whenever this coil is placed in a magnetic field followed by this north pole and south pole, this is going to generate some voltage. So this voltages will be bidirectional, and the commutator action is actually making them unidirectional. So this fundamental principle of brush type DC motor. Now, due to the limitation of the brushes and the contact resistance and the amount of power and current that can be handled by these brushes, nowadays the brushless DC motors are more efficient, and that provides an electronic control or electronic commutation. So going next, this is the brushless type of DC motor, where you can see there are 3 phases of the winding, and according to which phase is excited, the north pole and south pole of this particular motor will be attracted and repelled accordingly. So based on this attraction and repulsion, the motor theory works. Actually, if you see this motor working, this can be explained well in 6 steps. If you can correlate this with mechanical engineering concept, if you have seen the 6-cylinder engine and all these pistons inside the 6 cylinders comes and goes one after another, right? And they happen to be operating synchronism, right? So this particular motor also works in a similar fashion, where you have 6 number of steps, where this particular arrangement will be like from current flowing from U phase to W phase, and another one is U to V. And if you follow the sequence from 1 to 6, the motor will be rotating in a clockwise direction. And this particular thing can be explained in a better analogy like a donkey and a carrot system. So if you might have heard of this story where there is a man sitting on the donkey and carrying a carrot, and the donkey never catches the carrot. And in the process of catching the carrot, the donkey actually moves ahead, right? And the same thing happens with the brushless DC motor. The moment you energize these 2 phases, then the resultant flux is in this direction. And when the rotor achieves this particular direction by magnetically aligning this, the next moment you switch to another phase, and then the resultant vector will be somewhere here. So this is how the brushless DC motor is going to actually function. And after you have understood in a better way about the motor functioning, then you can understand how the motor torque will be controlled. So some of the recent developments in the brushless DC motor, with this won't be a 6-step control. This will be a very smooth control, where the sinusoidal back EMFs are applied to this winding, and this particular resultant vector will rotate smoothly, not in 6 steps like this, but it will rotate smoothly, and you will get less torque ripple. So this is going to provide a very smooth torque. If I go into the detail of the motor torque control, this particular theory is in turn going to control the entire vehicle, right? So let's imagine that this is a motor, and on the shaft of the motor you have some mechanical power transmission arrangement, where you have a chain drive or belt drive, and this is going to drive your wheel, right? So from the motor to the wheel, there will be an arrangement. So controlling the motor actually controls the entire vehicle. So how the controlling of the motor happens? So let's imagine that you have a 24-volt DC supply, and you will be you have connected the battery terminals to this particular system. And if you see the entire control architecture, this is the entire control architecture, where you will be taking many inputs from the motor. That may be the motor temperature, that may be the motor uh, position or speed and torque generated by this, and that there will be an input from the user also, which is a throttle input. And based on this sensors, voltage, current and position sensors and the throttle, there will be an error generated based on the difference between the set value and the actual value present. That error will be amplified by an error amplifier, and then it will be processed in a PI controller. And this particular PI controller is going to issue the signals. So this is the brain of the system. This is the power architecture, or this we can say the power electronic converter system. So here you can say this particular arrangement is a multivariable closed loop control with a PI type control. This is just a simple illustration. The actual vehicle may be having more complex system. So there will be a C program running on the embedded target hardware. For example, this is a Zilog microcontroller unit here. So this particular microcontroller unit is going to control the inverter, which in turn controls the motor, and which actually controls the entire vehicle or the speed and torque of the vehicle. So what happens here is, you can imagine the hands and legs, right, or the powerful muscles are performing the power task based on the signals received from the brain. So this is the heart of the system or brain of the system, and these are the hands and legs, or here you have a muscular power, and these are the control systems. So the control system is implemented in a microcontroller unit. This is called an MCU, and the power system comes with the MOSFET bridge inverter. So basically this requires a three-phase supply, and usually we have a DC voltage from the battery. So this DC has to be converted into the required AC. And the advantage of the power electronics technology is if you directly connect this battery to a DC motor, there is no control implemented, right? So the motor takes whatever amount of power it wishes to take, right? Or whatever amount of load is connected. But actually using this power electronic converter, you are feeding only that much of energy which is required, right? And this is going to save a lot of amount of energy, and this is where comparison of the efficiency comes, right? So usually this petrol engine or diesel engine vehicles are, according to the energy equations, they are let's say 30 to 40% efficient, the highest efficiency vehicles. But this electric vehicle, considering the n amount of charge stored in a battery, this particular entire system can be more than 90% efficient. And this is where you save a lot of amount of energy. And yes, obviously this electrical energy will be generated from power plant or a coal-fired power plant. But yes, definitely this will be much more efficient and much more cost effective if you consider the running cost of a vehicle. So this is about a motor. Now let's move to the next part, which is a battery world. So battery is an amazing world where you have uh, many different chemistries or recipes with various characteristics. Only few formulas which are successful, they are converted into the commercially available cell. So like the remote control cells, which are of AA and AAA type, these are lithium ion cells. I'm going to show you in the next few points. So this particular cells are like small coin type cell to maybe your mobile phone battery, or this can be as large as greater than 20 kilogram of very high capacity cell. One cell usually has very low voltage, and that will be very difficult to satisfy the automotive requirement. To run an entire car, you will require many cells, right? So many cells connected in series and parallel that will form a module, and this is going to make a battery pack. And this battery pack will be delivering the power to the motor. So here you can see the different types of cell. This is a cylindrical arrangement where these are very popularly known as 18650 cells. This is 18 mm in diameter and 65 mm in terms of its height. And then there are different types of cells based on the form factor of whether they are prismatic type or pouch type. So normally the cell phone batteries or you will find this pouch type cells, and the laptop batteries you will find this cylindrical types of cell. So here I can show you one video where you can see pack assembly where multiple cells like this are joined together and a battery pack is made. So this many cells in series and parallel are connected together. They are put together, and there is a mechanical structure or arrangement which is going to hold these cells. After holding these cells, there will be electrical connections from the top side and the bottom side. There will be certain temperature sensors or series wires coming out of the group of the cells. These are joined together, and battery management system is going to sit above the entire battery pack, which takes care of the cells and which is actually the responsible element for the life of the battery. And then there will be an enclosure and arrangement for the connections, and this particular battery pack can be used for a bicycle application. So where you will see the 24 volt and 36 volt battery packs used for this particular vehicle application. So this is just an introduction to how a single cell like this is transformed or is converted into an entire battery pack for this particular application. So the role of the mechanical engineer is make this particular battery enclosure, which is in terms of which better manages the heat coming out of the cells, which also takes care of the space between these two cells. Maybe a large battery pack like a Tesla vehicle will require active cooling system, right? So this is the battery related things. Now, next going ahead, the state of the charge or theory behind the battery pack. Uh, let's say this is a cell where you have a high amount of current entering to the battery, and the V voltage is gradually rising based on the amount of charge this particular cell is acquiring. So the same differential equation applies where you can see where voltage and currents are correlated. This can be compared with a glass which is full of the water. So here if you can see what happens if you are pouring the water inside a glass and the level is gradually increasing. Similarly, if you are charging the battery with high current, the level of the voltage is increasing. So based on the voltage of a typical battery, or based on the uh, ml mark over here, you can say this is how much of milliliter of water you have poured into the glass, right? And similarly, you can suggest how much percentage of the glass is full. Similarly, you can say how much percentage of the battery is full. So this is an analogy between the state of the charge, like with glass water. So it's very easy to convey that how much water is inside a glass, right? The accuracy of the water level, right? Imagine you are pouring the water and you wish to get the idea of exactly how much is the state of the charge, or how much is exactly is the level of the water. So to calculate it accurately, you have to allow the water to get settled, right? There has to be no ripple around it. And then you can estimate what is the exact level of the water inside a glass. The same thing applies to the battery as well. Whenever you are charging the battery, and if you are estimating the state of the charge, yes, there will be an error estimating it. So the same thing happens when the glass is going to get empty, right? So let's imagine you are drinking the water, and if you have reached to the state where say 1 or 2 drops are only left, where you can say the glass is still having 1% or 2% of the water, right? Which cannot be taken out, right? So The similar problems or similar things happen with a battery as well. If you have a very low state of charge, let's say for your mobile phone battery, which is less than 5%, and you really don't know when your phone is going to get shut down, right? Estimating the state of the charge at very low voltage and at very low state of charge, that is going to make a huge amount of error. The same thing happens when the battery is full. So if you are pouring the water to the glass and the glass is nearly full, then it's difficult for you to get the water at the same rate, right? So when you are charging a typical battery, you have to wait till the 80% capacity, and then the rate of change of the water coming into or current flowing into the battery, that has to be very limited. So that has to be very slow. The same thing happens when you go to a petrol pump and when you fuel your tank, right? So approximately 80 to 90% of the fuel will be flowing at the high rate, and once it is filled up, then the rate will be very low to calculate the exact amount of petrol that will be delivered in your petrol tank. So this is about state of the charge and the remaining capacity of the battery. So usually it is termed as SOC, and the 100% of SOC, and the reverse other term is called the depth of discharge. So that is 1 minus state of the charge in terms of percentage value. So coming to an end, the transportation electrification. What is the role of the mechanical engineering graduate? So yes, the automotive world is of mechanical engineers. Earlier, the electrical and electronics engineer used to get less opportunities, but now the opportunities are open for them as well. And yes, opportunities exist for mechanical engineers as well. So what exactly the mechanical engineer has to do at electric vehicle company? So here I have tried to list it down some of the points where what exactly the mechanical engineer graduate will be doing. So the first task is to model or to calculate the vehicle power requirement, right? So how much power will be required by a vehicle based on the acceleration required, based on the weight the vehicle is supposed to carry, based on the gradability, and based on the air drag and rolling resistance, and above all, the pattern in which the driver is going to drive the vehicle. So this really helps an electrical engineer to estimate the motor capacity, and based on the range, the battery capacity. So this is the very first step. The mechanical engineer has to model this entire mechanics of the vehicle or dynamics of the vehicle into MATLAB or such kind of tool. So this is the very first role the mechanical engineer has to perform. The second is the power transmission from the motor shaft to the wheel in case of the high power application like car and the commercial vehicles or bus and truck. So you must be knowing about what is the RPM and torque at the motor shaft and how much is required at the wheel, right? So you will be basically doing some calculation for the gears, right? So that is a role for the mechanical engineers. The motor manufacturing and the thermal management of the motor. So yes, motor is only electrical when you consider the input terminals. The rest of the part of the motor is all mechanical. So mechanical engineers has to do with the manufacturing of the motor, starting from its capacity to finite element analysis of motors, which can be jointly with electrical engineer or electronic engineer. When with electromagnetic analysis, you will be joining the FEM analysis for the motor as well. Yes, the motor gets heated up depending on the losses and depending on the speed and acceleration you are trying to get out of the vehicle. And yes, you have to take care of the cooling, active or passive cooling of the motor. So the motor has to be cooled down for its better life, and the same applies to a battery as well. So the battery pack assembly, where I showed a video, there you can understand what type of arrangement is required for a battery pack. And yes, if you draw very high current from the battery, or if you are charging the battery at very faster rate, the batteries are going to get heated up, right? And the thermal management is again the key for better life, right? So the thermal management here actually is a very big topic where you can analyze for active cooling the computational fluid dynamics, and where you have to consider the motor controller cooling as well. You have to consider the charger cooling as well. So the motor and battery pack systems are to be cool, right? And this thermal management is one of the aspects where mechanical engineer has to perform. So other than this powertrain, the steering, suspension, and braking, etc. Yes, that goes to the background of a mechanical engineer. So these are some of the roles and opportunities for the mechanical engineering graduate.